Hello, everybody, and welcome to our last new chapter in the textbook, Chapter 9, on hypothesis testing for sample means. Now, in fact, the statistics textbook covers hypothesis testing for sample means and sample proportions. The only area we're going to concentrate on is doing a hypothesis test about a sample mean for both the normal and t-distributions. And I'll describe some of the basics right here and show you how to use the Excel program that I've written for you guys in order to be able to use this. Now, don't forget that by Monday of the 9th week, you should have completed the online quiz 4. Actually, I've updated that to Friday this week. Complete the Chapter 8 web-assigned homework. And by Friday of this week, you should have watched the Chapter 9 lecture and completed the Lecture 8 form for attendance. So the first thing we're going to talk about is the nature of hypothesis testing and what it's all about. What a hypothesis test is when somebody makes a claim, how do we know that that claim can be believed? And one of the things that we've covered when we talked about Chapter 8 was in confidence intervals. We created an interval which gave us some level of confidence, an interval estimate which gave us some level of confidence that we could potentially include the actual population mean if we were given information about a sample mean and standard deviation, and perhaps some information about the type of population it came from. Let's say that the mayor of a town makes a claim that the mean yearly income of all residents is $50,000. How far off should let's say they hire a statistician to verify or not verify this claim, to refute this claim? What should happen? Well, if the mayor is $100 off, should he be said, plus or minus, $100 off, should he be said to be incorrect? How about $1,000 off? How far off is too far off? Well, a hypothesis test is set up to show us a way to use our confidence interval estimates in order to verify whether or not a claim about the mean is actually true or not. So we need to define a few terms. First of all, we have something called a null hypothesis. A hypothesis is a guess. It is an educated guess and one that to be tested. This is the science part of statistics. We are, in fact, coming to some sort of conclusion, and we want to test whether or not that hypothesis, that guess, is correct. Now, if there's either a null hypothesis or an alternate hypothesis. That is, if we make a claim, then what is the alternative to our claim? A hypothesis to be considered as an alternative to the null hypothesis, we use the symbol H subscript A to represent that alternate hypothesis. In a hypothesis test, the problem in a hypothesis test is to decide whether or not the null hypothesis should be rejected in favor of an alternative hypothesis. Now, in fact, we are kind of like a jury right here. One of the things that we're looking for if we are testing a hypothesis is not whether a claim is true or false, but really whether or not we've got enough evidence to reject the claim of the null hypothesis. In fact, we act kind of like, as statisticians, kind of like prosecutors. We're trying to prove not necessarily defending either we're not trying to prove guilt or innocence, right? In a court of law, sometimes we're just trying to prove guilt or not enough evidence of guilt. Well, here, true, is the hypothesis, the null hypothesis true, or is there enough evidence to reject that null hypothesis? So there are two types of errors that we can make when we're doing this. They're called type 1 and type 2 errors. A type 1 error is the error where we reject the null hypothesis when in fact it's true. And there's a type 2 error, which is not rejecting the null hypothesis when in fact it's false. Now, this little table right here I think actually is a really good illustration of it. Let's say that we're looking to either reject or not reject the null hypothesis. Well, let's say the null hypothesis is actually true. Right? If the null hypothesis is actually true, what could we say? Well, if we do not reject the null hypothesis, we've got the correct error. But if we reject the null hypothesis when it's actually true, we've made a type 1 error. Now, on the other hand, if our null hypothesis is false, and we do not reject that null hypothesis, we've made a type 2 error. But if we reject the null hypothesis, we have made the correct outcome. So we want to be very careful. We want to get into the correct outcome. And the type of testing we're going to rely on is the one that's called a type 1 error, testing for type 1 errors. So a level of significance test, we say the probability of making a type 1 error, that is of rejecting the null hypothesis, is called the significance level, or alpha, of a hypothesis test. Now, if we say the probability of making a type 2 error is beta, right? That's alpha. This is the Greek letter beta, right? For a fixed sample size, the smaller we specify the significance level alpha, the larger the probability of beta and of not rejecting a false null hypothesis. So there is a relationship between them. So what conclusions can we reach? Well, okay, if we suppose we conduct a hypothesis test for a small significance level. If the null hypothesis is rejected, we would conclude that the data provides sufficient evidence to support the alternate hypothesis. If the null hypothesis is not rejected, we conclude that we do not have sufficient evidence to support the alternative hypothesis. Typically, the way that we think about this is that we look at it as if, again, we're in a jury. We say that, we ask the question, when we're given a null hypothesis, do we have enough evidence to reject that null hypothesis? And we can say in favor of the alternate hypothesis, but really, we're either going to reject the null hypothesis or fail to reject the null hypothesis. Well, let's talk about how we would set this up. Here's a description. Previously, an organization reported that teenagers spend 4.5 hours per week on average on the phone. The organization thinks that currently the mean is higher. 15 randomly chosen teenagers were asked how many hours per week they spend on the phone. A sample mean of 4.75 hours with a sample standard deviation of 2.0 is found from this sample. Let's conduct a hypothesis test. The only question we want to ask right now is, well, what should be the null and alternative hypothesis? Well, are we saying the average is 4.5 and that the average is greater than 4.5? Well, no. Remember that this symbol right here, X bar, talks about the sample standard average, right? We're talking about a population, right? Whenever we're testing a hypothesis, we're looking to see what the setup is for our mean. Well, if that for our population mean, right? And that means that we're looking at mu. So right away, A is out. That's not going to work. We're not going to be able to do that, right? What we're looking at is something that deals with the mean. So what is our claim? Well, the claim is that the organization thinks that the mean is higher than what? 4.5 hours per week on average on the phone. So we're testing how many hours on average, how many average hours per week teenagers spend on the phone. And we're saying that they currently think it's higher. So the claim is that it's actually higher than 4.5. Well, if it's or at least 4.5 hours, right? Well, if it's at least 4.5 hours, that means that the alternative to that is that the mean must be less than 4.5 hours. Well, now, why wouldn't we choose any of these other options? Well, let's look. If the null hypothesis is said to be 4.75, then we're basing it on the sample mean, not the population mean, so that's out. We're saying, is the mean equal to 4.5? Well, that could be, but the alternate hypothesis right here is kind of a giveaway that this is not what we want, right? Because if we're saying that we think that it might be higher, then our alternative hypothesis should be that it's lower. And since that second part is untrue, we can't accept D at all. So the only one that works right here is answer B. So we'll talk about this critical value approach to hypothesis testing and explain what that is, and another approach called the p-value approach in the next video.